Hello 108 students, Mr. McHugh here working with you on our last page of section 7.3, and page 4 is what we're going to tackle here. Objective number 4 is asking us to remember what do we do when we see a negative exponent. And if you see one standing alone by itself, you kind of hopefully remember my words, we don't care for negative exponents, and I could write x to the negative 1. I could write the reciprocal. Hopefully you remember these words, and you change the sign of the exponent from negative to positive. Okay, now that's fine. Most of you are probably pretty comfortable with that. Then what happens here is they try to throw a little zinger to us here, and you look at this example 4a, and your first inclination might be to say, hey, m to the negative 1, take it down to the other half, okay? Write the reciprocal, okay? But there's a big difference going on here, and the big difference is this. You see that plus sign, and you see the minus sign up here. You've got separate terms up in the numerator, down in the denominator. That is not the same as if I wrote this problem. I'm going to go on a little side tangent here. I want to make sure you see this difference. Here's negative 1, and I'm going to put parentheses to overkill this to help you follow it. Here's p to the negative 2. Now what I'm doing, this is a new problem, but instead of having an addition, this is what you're used to seeing, assumed multiplication. You're used to seeing a problem looking exactly almost like you're working with, but a big difference. I'm putting the parentheses as overboard, I'm putting multiplication as overboard, but this is what you were used to seeing, and then you would go ahead and follow the multiplying by converting from negative exponents to the reciprocal with a positive exponent. Okay, now if I was going to do that, let me try to work down here a little bit here. Okay, I'm sorry I'm on this side tangent here, but let's just follow me here for a little bit now. I just want you to see, because it's multiplication, you would go and take m to the negative 1, you would drop it down to the first. Because it's p to the negative 2, you would drop it. Okay, up here, because you have multiplication is the key thing. This is a single term up in the numerator, a single term down in the denominator. So therefore you apply the rule that you're comfortable with. Now the 2, by the way, would stay down here as it's positive. M would go up with a positive exponent, and that negative 1 would stay down right here, and then you'd have p to the first. Okay, now once you got that, you have m squared divided by m would be m. I like to draw that fraction bar first. What goes up in the top half? M p divided by p to the first divided by p squared is p to the negative 1. Oops, wait a second, I made a mistake here. I thought I made a mistake. No, I didn't. Okay, so that would be there, and then you would have negative 2. Okay, now then what would happen here is you'd bring the p up. Upstairs you'd have mp divided by a negative 2. And of course the negative come up here. Okay, now my key point here, don't worry about all this detail here. My key point here, I just really wanted to show you that if there was multiplication, you would follow the rule that you would have. Okay, now you're not going to see any problems like this, so just I want you to recognize there's multiplication here. Here we have addition. You have to treat it separately, and what you've got to do is take that m to the negative first, keep it all above the fraction bar. Okay, you're above the fraction bar. M to the negative 1 converts into 1 divided by m to a positive 1. Okay, p raised to the negative 2, you write it as the reciprocal with a positive 2. Now that's the key thing that you're learning here in this section. Down here in the denominator, do the same thing. The 2 stays in the numerator, but you're down on the bottom half. M to the negative 2 goes down with a positive. Okay, hopefully everybody's seen what I'm doing here. Negative 1 stays there, p to the negative 1 becomes p to the positive 1. Okay, so that's the big conversion step. Now once you realize that and you apply this correctly, again the plus and the minus signs, what triggers this technique here. This again was multiplication, so you're not using this, but I just wanted to show it. Over here you've done problems like this. You now have how many rational expressions up in the numerator? Class, count them for me. Hopefully you're telling me what? Oh, that's a negative sign, sorry. I'm pointing at that. How many? 2 rational expressions, therefore use method number 2, multiply by the LCD. Okay, You guys hopefully remember how do you determine the LCD? Now I just wrote it, m squared times p squared. How did I get that? M to the first, p squared, they need to be factors. So p squared, p to the first, you pick the highest exponent. Same thing with the m squared, m to the first, you pick m squared. Okay, there's your LCD right here. Put it multiplied by the numerator and the denominator. And by the way, I forgot to mention this before, when you do that, when your LCD is up in the numerator and the denominator, it's equivalent to 1. That's a key point I forgot to mention. Therefore, that's why you're allowed to do it. In essence, you're multiplying the big rational expression by an equivalency. Okay, with that said, you're doing distributive property. And distribute the LCD. So I did that. So you've got 1 up here in the numerators, you've got a 2, and you got a 1, so you get m squared, p squared, p squared. There's the 2, m squared, p squared, m squared, p squared. Watch your signs. Okay, now I like to do it this way here because I left the denominators alone, and my goal now is to see simplification. You're supposed to clear out the rational expressions. The fractions are supposed to go away. Well, does that happen? It should. M squared divided by m is what? M. 1 left. You got the p squared. Look over here. P squared, cancel out. Over here, m squared, cancel out. P squared divided by p to the first is what? This is out. That's out. You're left with an m. So who's left standing? M, p squared, m squared. Down here in the denominator, what's left? 2p squared. Over here, m squared. Oh, don't forget the minus sign and a single p. Okay, now, got to show you a little more here. I want you to forget about this. In fact, I think I'm going to go, I'm going to go ahead and go to a different color here to illustrate this. Oh, I don't know. What do you think? Green maybe? Let's try green. Now, green is this. This is your answer to the problem right here. Now, if you look at this, you might say, hey, Mr. McHugh, you're not following your rules. Aren't you supposed to factor? And the answer is yes. And let's try it. And you would need to do this, okay? Now, here's the story. Sometimes you got to factor and see what you got with. Now, I would see m and m squared. I would pull out an m. I'd be left with p squared plus m. Okay, and then down the denominator, do I see a GCF? I see what? P. And what would be left inside the parentheses? 2p. P times 2p is 2p squared minus m squared. Okay, I would do this. You have no choice because you're looking to try to find simplification. Now, here's the kicker. I wish the authors in my math lab would tell you leave the answer in factored form and you'd be done. For some crazy reason, you look at this and you kind of go, okay, I'm ready to simplify. I'm looking to cross out like terms and I got nothing. You cannot simplify. You can't do it. So when you factor, but you cannot simplify, you're left to resort back to the previous answer. That's a tad frustrating. I apologize for that. If I was in charge of my math lab, I would definitely leave it like this. I just think it's a little cleaner. Okay? If you could factor it, you factor it, and then that would be your answer. But unfortunately, if you factor and you do not simplify anything, you revert back to the previous answer. Okay, so with that said, we have finished section 7.3. Give yourselves a double check mark here. You've worked hard. You've dealt with complex fractions. Hopefully you're comfortable with method 1, method number 2, and on this last page dealing with negative exponents. Okay, Mr. McHugh, got to sign off for now. I'll see you when we start section 7.4, and we are going to deal with equations that have rational expressions in them. Okay, I'll see you then. Bye-bye.